Hello class 8. Welcome to the second part of the chapter, Atomic Structure, chapter number 4, Chemistry. So today we will deal with Rutherford nuclear model of an atom. Okay. Now, on the basis of his experiment, Rutherford put forward the nuclear model of an atom. The model described the structure of the atom as follows. Number 1. So according to Rutherford is explaining about how an atom look like. What is it made up of? So he says there is a positively charged core in the center of an atom called the nucleus. So in the center of the center of an atom, we have the nucleus. Nearly all the mass, the entire mass of the atom is concentrated in the nucleus. The electrons revolve around the nucleus in a fixed path called orbits or shell, like the planets that revolves around the sun. So this theory, this model, Rutherford model of an atom, is also known as planetary model of an atom. And lastly, since the atom is neutral, he says, Rutherford said, the number of electrons is equal to the number of protons. Now we come to the Bohr's atomic model. A Danish physicist, Niels Bohr, further developed Rutherford's model of an atom. He worked on it more. So he proposed his atomic model. Now what did he say? So according to Bohr's model, electron revolving around the nucleus occupies particular orbits which are said to be shells, and he labeled the shell as K, L, M and N starting from the innermost shell. Each orbit or shell is associated with a fixed or a definite amount of energy. Therefore, these shells were also called energy levels. Okay, that was according to Bohr. Now, we talked about the discovery of electrons, we talked about protons and the different models of an atom. But now we will discuss about the discovery of neutrons. The electrons are positively charged, electrons are negatively charged, protons are positively charged, whereas neutrons, they are neutral, okay, inside the nucleus. So Rutherford concluded that virtually all of the mass of an atom is concentrated in the nucleus. That's what he said. In 1932, James Chadwick, an English physicist, discovered the subatomic particle called neutrons, which does not have any charge. So he found that the particle has no electrical charge and has a mass approximate to the proton. So what is the mass also is almost equal to the mass of proton. So let us come to the properties of neutron now. Neutrons are present in the nucleus of an atom. The atoms of all elements contain neutrons except an atom of hydrogen. Hydrogen does not have neutron in it. Okay, please remember, hydrogen is the only element which does not have any nucleus. Rest of the atoms of all the elements will have nucleus in it. So neutron. Okay, hydrogen does not have neutron in the nucleus. Rest of the elements will all have neutrons. The electrically neutral neutrons in its nucleus. So a neutron carry no charge. It does not have any charge. So it is electrically neutral and has the mass of 1.675 into 10 to the power of minus 27 kilograms. Okay, a slightly less than protons. Slightly more than the protons, because the mass of proton is 1.672 into 10 to the power of minus 27 kilograms. So these are the properties of neutrons. Okay. The nucleus and the extranuclear region. Now, nucleus, as you know, it's in the center. This is the nucleus, isn't it? This is the nucleus. And inside the nucleus, we have protons and neutrons. Nucleus is made up of protons and neutrons, positively charged protons and neutral neutrons. And around the nucleus, we have shells. And in the shells, we have, or orbits, we have electrons revolving around the nucleus in a very high speed. And we have the names given to different, this is the first orbit. This is the first orbit, K. The second orbit, or L. Third orbit, M. And the fourth orbit, N, and so on. Okay. So, let us talk about the nucleus. The nucleus of an atom consists of protons and neutrons. The protons and neutrons are collectively known as nucleons. So, what is the nucleus? The heaviest part of an atom is called, the central part of an atom is called the nucleus, and inside, within the nucleus we have protons and neutrons, and this is the heaviest part of an atom. And protons and neutrons together makes the nucleus, and those particles which makes the nucleus are known as nucleons. So collectively, protons and neutrons together, they are called nucleons. So almost the entire mass of an atom is concentrated in the nucleus, since electrons which revolve around the nucleus in the different shells, they have negligible mass. They are very, very light. They have negligible mass. So the positive charge of the nucleus is due to the protons present in the nucleus. Now, the charge of an electron, we know that it is negatively charged, that revolve around the nucleus. And then within the nucleus, because of the protons, because neutrons does not have any charge. So since protons are positively charged, the entire the charge of the nucleus will be positively charged. So there is a force of attraction between the nucleus and the revolving electrons, because opposite charges, they attract each other. So the positive charge of the nucleus is due to the protons present in the nucleus. And as we all know that neutrons, they do not have any charge. They are electrically neutral. Now we come to the nucleus, and then we have the extranuclear region. The region of the atom beyond the nucleus is known as extranuclear regions, where we find electrons revolving around the nucleus in a fixed path called, or the shell called, orbit. So in an atom, the number of protons inside the nucleus is equal to the number of electrons revolving around it. Therefore, atom is electrically neutral. And please remember another fact, that when we talk about sodium, the atomic number is 11. So we have the nucleus, and within the nucleus we have 11 protons. Okay, because the atomic number is 11 means we'll have 11 protons, and then around the nucleus we have different shells, and in different shells we have different number of electrons, and total number of electrons is in the atom of nucleus is also 8. So when we talk about the number of electrons, also 11, number of protons is also 11. So in an atom, in any atom for that matter, the number of electrons is always equal to the number of protons. So therefore, positive charges are always equal to the negative charges. Therefore, the atom as a whole will have no charge, means they are electrically neutral. So in protons, in the sodium nucleus, we have 11 protons, because the atomic number is 11. Atomic number means actually the number of protons or the number of electrons. So we will have the same number of electrons. So 2, 8 and 1 electron we'll have. We'll talk about electronic configuration in the next class. So total number of electrons 8, 9, 10, 11. So in any atom, the number of electrons is equal to the number of protons. So therefore, atoms are electrically neutral. Okay. Now we come to the composition of nucleus. As we know, the nucleus of an atom consists of protons and neutrons. They are called, together they are known as nucleons. So the number of protons and neutrons in an atom determines the atomic number, or atomic number and the mass number of an atom. So first we talk about the atomic number. We have already dealt with this in class 7, so we'll revise it. Atomic number. What is atomic number? So atomic number is the number of protons present in the nucleus of an atom. So that is called the atomic number. Now, it is represented, atomic number is represented by the capital letter Z. Atomic number is represented by atomic number Z. Okay? Atomic number is represented by Z. It is the number of protons, or it is the, since we have total number of electrons and total number of protons are the same. So therefore, atomic number represents the total number of protons or the total number of electrons in an atom. The next one is we come to the mass number, or the atomic weight, which is represented by the letter capital A. Okay. Now mass number is the total number of protons and neutrons. It is the number of protons and together with the neutrons in the nucleus of an atom. So the number of nucleons, the total number of nucleons in the nucleus, the number of protons and the number of neutrons together is known as the mass number, and it is represented by capital letter A. So how do we find the number of neutrons now? So if you want to know the number of neutrons in an atom, the number of neutrons is equal to number of neutrons in an atom, in any atom, is equal to the atomic mass or the mass number A minus the atomic number Z. Please remember this. Okay, it's very, very simple. So number of neutrons in the nucleus of an atom is equal to the atomic or the atomic weight or mass number minus the atomic number. So mass number minus atomic number is the number, you get the number of neutrons. Okay, all right. So in the next class, we will talk about the symbolic representation of element and the electronic configuration in detail. Okay. So I hope you have understood the Rutherford's nuclear model of an atom, the Bohr's model of an atom, the discovery of neutrons, the property of neutrons, the nucleus and the extranuclear charges, the atomic number and the mass number. That's what we dealt with today. So thank you for watching. I hope you've understood. See you in the next class. Thank you so much.